Hello, welcome back to the channel and welcome back to this series on differentiation. So in our previous episodes we've looked at what gradients are and how they relate to differentiation. We've looked at simple differentiation, the chain rule, product rule and quotient rule. So the next part is implicit differentiation. So this is a technique that's taught at A2 level, which is the second year of A level. And let's consider this. You have y plus 2x squared y cubed is equal to 7. And we want to find dy by dx. So the issue we're going to have is we can try and rearrange this so we have y is equal to something in terms of x. But the problem we're going to have is we can't actually do this. So therefore we have to use something called implicit differentiation. So I'm going to start off by just demonstrating it on this term here, which I'll circle in blue. And we're going to go through it and see what we can come up with it. And what we'll find is that we're going to have to use a combination of the chain rule and product rule to solve this. So let's consider this 2x squared y cubed. So if we wanted to differentiate this normally, we would have to take this y over and then we find the cube root and that's all fine. But because we're considering it in this context, we're going to have a bit of a problem. So first of all, we can look at it from the chain rule, the product rule point of view. So let's say that f is equal to y cubed, and let's say that g is equal to 2x squared. So we need to find f prime, which is going to be a bit of a problem because how do we differentiate with this with respect to x? So let's go straight over to the g prime. So in this case we're going to have that 2 is going to come down, so it's going to go to 4x. And we're going to take 2 away from this power, 1 away from this power of 2, so it's going to go to x to the 1, which is just x. Now, let's consider what we have to do with this y cubed term. So this is where we have to use the chain rule. So we could try doing dy cubed by dx. And the problem is, this will have some dependency on x, but we don't know what that dependency on x is, which makes it difficult to differentiate. However, if I multiply this by dy by dy, which is again is basically doing the product rule, what we end up with is this is equal to dy cubed over dy. So I'm swapping this dy and dx, the order of them, and this is then going to be multiplied by dy by dx. And I can now do this because I can differentiate dy cubed, that's going to go to 3y squared, and I still have this dy by dx. So this is what our f prime is equal to. And therefore, I can differentiate from the product rule now, where we're going to have the f times g prime, so this is going to be 4x y cubed, plus, then we're going to go on this diagonal, so we're going to have 2x squared 3y squared dy by dx. So this is this term differentiated. So what we can find is that when we can come up with a simple rule for doing differentiation. So that rule is we differentiated first this combined function with respect to x, which is here. We then add it to the differential with respect to y, and every term that we've differentiated with respect to y, we put a dy and dx after it. So this means that this first term, so let's go back to the green pen, and I can rub this out. So, and I'm going to rub out this for the time being because we're going to need to do a bit of rearrangement. So we're going to start off this first term. So first of all, we can differentiate with respect to x, and that's going to be 0. We're going to add that to the differential of respect to y, which is just 1, and we're going to multiply it by dy by dx. So that's just going to be 1 times dy by dx is dy by dx, plus we got this term. So we've got 4x y cubed, so we're taking it from below. I can combine these two terms together, so the 6 and the 2, to go to 6. We've got x squared y squared, and if I differentiate 7, because you have to do the same on this side, if we differentiate the 7 with respect to y or respect to x, it's going to be equal to 0. And after this we should also put the dy by dx. So now we have an equation. So the question is, can this help us find dy by dx? So I'm going to rub out this part of the board. So we have two terms of dy by dx, so I can put that into a bracket. So I can go dy by dx, and then open the bracket. I need 1 plus 6x squared y squared. And I'm going to take this term over to the other side, so I'm going to make this equal to minus 4xy cubed. Now if I take this bracket down and divide by this, I end up with dy by dx is equal to minus 4xy cubed all over 1 plus x squared y squared. And I found my dy by dx. So this is how you do differentiation implicitly. So the rules are: differentiate with respect to x, as normally, so each term differentiate with respect to x. Then go through and differentiate each term with respect to y, and each term that you can differentiate with respect to y, put a dy by dx after. Bring the dy by dx terms together and form a bracket with those terms that have been multiplied by dy by dx together. Take all your other terms over to the other side of the equation and then divide through by your bracket, and you end up with dy by dx and your differentiation. So that is how you do implicit differentiation, or the tips for doing it at A-level. So in the next few episodes, what we're going to do is look at some examples of using differentiation. As always, thank you for watching. Please hit the subscribe button, and I'll see you in another video very soon.